This episode of Ham Talk Live is brought to you by Tower Electronics. For connectors, cables, and more, visit them at a Hamfest near you or call 920-435-2973 or online at pl-259.com.
It's Ham Radio with Neil Rapp. Here we go. Welcome to Ham Talk Live. Call in, let's talk. Neil's your guy. Ham Talk Live. Here we go on Ham Talk Radio.
Good evening, everyone. It's Ham Talk Live, episode number 98. Building satellites and the Fox D1D launch, with Jerry N0JY recorded live on Thursday, January 18th, 2018. I'm your host, Neil Rapp, WB9VPG. Thanks for tuning in to this episode of Ham Talk Live. Tonight, we're joined by AMSAT Vice President for Engineering, Jerry Buxton, N0JY, and we'll take your calls live in just a few minutes. Last week, if you missed the show, Doug Grant, K1DG, was here to talk about the World Radio Sport Team Championships. And if you ever miss a show, all you have to do is go to hamtalklive.com and you can play it on the website anytime you like. You can also catch the podcast version over on your favorite podcast app. We upload to Apple Podcasts, Stitcher, iHeart Podcasts, Google Play, TuneIn, SoundCloud, and we also upload to YouTube, and lots of other podcast apps get the feeds from there. So be sure to check that out and subscribe to us. Well, get your satellite building questions ready to go. After the interview, you can give us a call. It's not time to call yet, but let me give you the number so you have your dialing fingers ready. It's 812-NET-HAM-1. That's 812-638-4261. You can also Skype us directly at Ham Talk Live. You can also tweet us. We're at Ham Talk Live on Twitter. And I know the satellite folks, they love their Twitter, so we'll try to keep an eye on that tonight. So I will be back with Jerry right after this word from Tower Electronics right here on Ham Talk Live. This episode of Ham Talk Live is brought to you in part by Tower Electronics. Tower Electronics has been the Ham's dime store since 1978. When you need connectors, mobile and handheld antennas, cables, or adapters, visit Scott or Jill at a Hamfest near you. Or you can order online at pl-259.com or call 920-435-2973. Stock up on those supplies like PL259 and N connectors, SMA adapters, audio cables, soldering supplies, mobile antennas, and ham sticks. Their silver-plated N connectors are even used on the International Space Station. Tower Electronics carries MFJ, Comet, Daiwa, OPEC, Workman, and Ham Pro products. And don't miss their 0% off sale going on now. Tower Electronics, online at pl-259.com, proud to sponsor this episode of Ham Talk Live.
Sorry for the delay. Your host, Neil Rapp, is reading a book on anti-gravity, and he just can't put it down. Now, here's more Ham Talk Live.
Scott and Jill at Tower Electronics are sponsoring the show yet once again tonight. They help bring you Ham Talk Live each and every Thursday night at 9 p.m. Eastern Time. They're back out on the road. You can catch them this weekend in Fort Myers, Florida. Had the Hamfest there on Friday and Saturday, the 19th and 20th. And then they'll also be at Wheaton, Illinois on Sunday. And then on the 27th, on Saturday the 27th, they will be in both Arcadia, Florida and Collinsville, Illinois. But they're always at pl-259.com, and they're by the phone number 920-435-2973. Tell them you heard it on Ham Talk Live, and get your adapters, connectors, and whatever you need. Well, joining us tonight is Jerry Buxton, N0JY. He's been a ham since 1972. And Jerry says he enjoys giving to the community by sharing his God-given talents to help build ham satellites and help out communities with disaster response. Jerry says there's more things to do in amateur radio than he could ever get done, but he likes to bounce around between satellites and HF and CW and voice, digital, you name it. He operates as HK5JY from Columbia when visiting his wife's family, along with his XYL KD5FCQ. And Jerry is the vice president of AMSAT North America, in charge of engineering, and is also the Texas District 4 radio officer for RACES. So, Jerry, thank you for coming on Ham Talk Live tonight.
Good evening, Neil, and thank you for inviting me. Good to be here.
Yeah, we've been wanting to get you on here for a while, and the timing just worked out great because just last week, in fact, just a few hours after this show last week, Fox 1D was successfully launched, and been hearing and seeing some of the reports coming in on Twitter. Looks like a fabulous job by the team. Sean, KX9X, mentioned that he heard it with an HT and a rubber duck out in Connecticut, and, you know, just had it there without really aiming or trying, and some of the images that have been downloaded already from it have been incredible. So fill us in on the latest happenings on the first week of Fox 1D.
Very well. Fox 1D did launch at 3:59 a.m. UTC last Thursday night for us here from India on a PSLV launch vehicle. And at about 5:18 a.m., we expected that it came alive, and we did hear telemetry shortly thereafter. So once we had the telemetry downlink, it could officially become an AO, and it was designated AO 92 on Friday. One of the first things we do after we watch it run until we get a good pass over the U.S. is just look at telemetry that's gathered by all of the helpful hams throughout the world. We distribute Fox Telem software, which works with all of the Fox satellites, and in capturing the telemetry, the user can see what everything that's going on, but it also relays it to our central server and gives us the opportunity to check up on things even when it's not within range of the U.S. So when it came around the next day, we did put it into safe mode, and then shortly thereafter, we put it into transponder mode. Transponder mode, of course, is the mode that users are typically familiar with, and that is when it operates as a repeater, essentially a crossband repeater. And when we did that, we do a little bit of voice check out there, and one of the command stations, Drew Glassbrenner, KO4MA. He sits in his shack office there and pulls out his HT, and it has one of the quarter-inch aftermarket whips on it. Quarter-inch would be nice, right?
Yeah.
Quarter wave. Quarter wave, how's that?
That'd be some high frequency.
Yeah. Well, we're going there, too. I can tell you more about that later. So with 5 watts at 10 degrees elevation, he said, he got into AO 92 just fine. So it is nice and sensitive. Of course, when it's busy, that's probably going to be a lot harder to make a QSO that way. But nonetheless, it's working very well. And all of the Fox satellites have 500, 600 milliwatts output, so they're pretty easy to hear, even with a rubber duck, although you have to remember to point it around for polarity because it's not straight up and down like we're used to with our HTs down here. And the whole week then, we've been running through what we call the in-orbit checklist, and we do a number of tests. Fox 1D has more experiments than Fox 1A or Fox 1B did, which are AO85 and AO91. So we've been going through steps to test the experiments. The camera was the first one that we looked at early on, and as you mentioned, there have been some really nice pictures returned from that. The team at Virginia Tech, the team of students, we partnered with them, and they built and provided the experiment, as our Fox 1 satellites, CubeSats, are designed to be able to hold 4 slots of experiments. Whether one experiment uses one of them or uses all 4 of them, we can host experiments in there. So the Virginia Tech camera takes up one of those and looks out the top end, if you will, the plus Z end of the satellite. And the 320 by 240 pictures that they're returning are amazing. You can, if you don't see them with your Fox to Limb software, you can see them on the leaderboard AMSAT website. And I'll put in a little plug that anybody who does copy even a portion of a picture or any telemetry whatsoever, for that matter, with Fox to Limb is contributing, because once that all gets sent to the server, we will have hopefully enough frames that came from enough locations to be able to reassemble the picture. So that's why you can usually catch a full picture on the web page. And then we moved on to testing the Herky mode. Herky is an experiment from the University of Iowa that is going to measure or map the radiation belts. It's kind of a similar or a follow-on to what Dr. Van Allen had done back in the late 1950s. And the students put together an experiment. This takes up 2 bays. And it essentially, throughout the orbit, it's gathering data, and then we put it into a high-speed mode to be able to download that data, and that's what we were testing today. We ran it a little bit last night and then again today. And once we have confirmation from University of Iowa that everything's looking good with that, we'll check that off the list. We also have one more experiment that we created ourselves, AMSAT, and we call it Downshifter. Downshifter allows us to have an L-band uplink, 1.2 gigahertz. And that means that in addition to the typical uplink, of 435 megahertz with the downlink on 2 meters, we also have the option of turning on a 1.2 gigahertz uplink with the 2 meter downlink. They're mutually exclusive, so it'll be in one mode or the other. The L-band, the downshifter, as it's so named, is simply a down converter. And what it'll do is receive the L-band, down convert it to the 435.350 megahertz input of the stock receiver, if you will, on Fox 1D. And that will give us that opportunity to work with L-band. We'll find a similar one on Fox 1C, too. So we'll probably test that out. I'm thinking about tomorrow night to turn it on and give it a little try. Everything that we go through is laid out in a script, but we, depending on what the results are and what the opportunities are to command the satellite, we make a few variations on that. And I usually don't, unless we need help with the telemetry or we're going to do the photos or something, we don't usually broadcast it, because it's just a matter of we kind of see what happens when it comes up sometimes. I expect that by a week from today, we will be able to open it up for general amateur radio use. So everything's looking good so far.
All right, very good. And Robert Fitzpatrick says, we need satellite police. AO92 is a busy satellite, so need some traffic cops out there, I guess. Well,
hopefully we're the only ones keeping it busy right now, though.
Well, we hope until everything's checked out. Well, the main reason we wanted you to come on tonight was to talk about your particular expertise, which is building these things. So give us an idea of what goes into building one of these, particularly like Fox 1D. There's
quite a bit of work that goes into them. Let me start kind of at the beginning. The design, of course, the Fox 1s are AMSAT's first CubeSat design, and it was conceived back around 2009 by the then Vice President of Engineering, Tony Montero, AA2TX, who's now a silent key. And because of the success in what AMSAT helped create. As you may know, we've been building satellites for about 45 years, and we would hitchhike rides with them or for them on various launch vehicles, typically as ballast. But as it became more and more interest in space, that forces people to become paying customers. The CubeSat became a standard because that allows you to make something that just about any rocket can accommodate in that sense. So we went after that design, and in the development of the Fox 1, there are one of the things about building any satellite. Of course, you got to look at what your goals are. But for AMSAT, of course, it's to have a good working radio that will last a number of years. It takes a lot of time and costs a lot of money to get it into space. So while some experiments that are done, perhaps by some universities and such, are maybe a year's worth of interest, we're interested in keeping something up there for as long as the orbit will last at least. So the designs, you have to consider the radiation of space and the temperature swings, and a number of factors that can influence and degrade your electronics. That leads to careful part choices, a lot of prototyping, and a lot of testing to make sure that goes together right. The CubeSat itself, being 4 inches by 4 inches, is a pretty tiny box to put all that stuff into. So the circuit layout and everything is quite a bit of work as well. We do subject it to a lot of testing. It has to be able to survive the launch vehicle, which can be very violent, actually, the ride to space. Compared to what you're used to thinking, it can be quite a few G's of acceleration where the spacecraft are riding. So we have to make sure that it doesn't fall apart in vibration testing, and we test for shock and various things depending on the launch vehicle. The number of hours that are required to put in, to make sure that all comes together are what leads to part of the reason that it takes some time to get to orbit. Because again, we don't want to put something up that's not going to work well. The design of the Fox 1 satellites then, was to build more than one, because once you're starting to put this effort and money into the research and development, you get much better turn on investment if you make more than one of them. So there are a number of engineers, and everyone who works on these is a volunteer. Everyone. They're working on them. It's similar to working on any amateur radio project you might work on, where you build something, and but we've got a large group of people doing it because there are so many different things that go into it, and a lot of different skills that are involved. It requires quite a bit of understanding and technique, because once you launch it, you can't fix it. If you build a project in your shack, for example, you might turn it on, it doesn't work quite right. Well, you can change things. Even though we test it right up until launch, if something doesn't go quite right in space, of course, we're stuck with what it is. So
I don't know. There might be some people out there that would volunteer to say, "Hey, you know what? I'll just go up there and fix that."
Yeah, that's true.
I don't think that would go over, though.
Well, it's actually, if it costs as much as it does to launch a CubeSat, to launch a human to fix it, you may as well just probably build another CubeSat. Huh?
That's true.
So the amount of it is like a big project, but it's just got a lot more tricks, a lot of different things to think about that you don't typically encounter, I guess you'd say, in a standard radio, more or less. What we're used to dealing with as far as ham radios. We design it to be able to hold the experiments. This gives us opportunities for launches because of the NASA CubeSat Launch Initiative program, where it's part of their outreach to further education and exploration and such. The STEM education that comes with students developing and flying an experiment board is part of the value that NASA is looking for, that they're willing to pay for the cost of a launch. And so that helps us to put that up there. We're, of course, very great with radios, AMSAT is, and therefore, as far as bringing telemetry down, it's an excellent way to do that. And it benefits education and learning for everyone throughout the world, really, because the ham radio in itself, of course, is obviously a place to foster education as well as goodwill and communication and to learn things. So just putting a transponder in space throughout is an opportunity for everyone to be able to learn something from that.
Excellent stuff. And, you've got to also get into, some of the physics of maintaining that orbit and keeping everything going. So how do you make those little adjustments and keep those things running for years and years?
The CubeSats that we're flying are passive. They don't have any attitude control. The Fox 1, they don't have any propulsion. So, and that's true of a large number of the CubeSats that are launched, especially the size that they are. It's difficult to put that in there, plus the number of radios and experiments, et cetera, that we do. But so it's launched and it's deployed, and essentially it will just float around in that orbit, if you will, until the orbit eventually decays. And there is no control of it. Now, we do have control through the sense that there is a magnet, a bar magnet in each one of these that's along one side. And what that does is generally keep the plus Z axis, or the top end as we kind of think of it here on Earth, pointed toward the North Magnetic Pole. So that keeps it stable in that respect. We also use the photon effect of photons reflecting off of different darkness materials through the sides of it. If you look at a picture of a Fox, you'll see we have gold, and then we have some darker colored rails and such. And that imparts a bit of a spin to it. So, of course, the spin around the axis provides stabilization as well. But that's the maximum of that. If we have no way to control it, to boost it or re-enter it or anything like that, it takes its own course and comes down when nature and physics, that it's time to do that. With our future satellites, we'll get into more of that, but we'll talk about that in a bit.
Okay, very good. Well, some great information and learning a lot about building satellites here with Jerry Buxton, N0JY, and we'll be back to talk some more with him and take your phone calls and tweets and whatever else you have. We'd love to have you participate. Again, that phone number is 812-NET-HAM1, 812-638-4261, and we'll open up the phone lines right after this word from the National Voice of America Museum of Broadcasting right here on Ham Talk Live.
The National Voice of America Museum of Broadcasting, located in Westchester, Ohio, just north of Cincinnati, is only 2 minutes off I-75. The museum is the former home of the Voice of America Bethany Relay Station. Tours are now available every Saturday and Sunday from 1 to 4 p.m. Eastern Time. You can see the control room, a 200,000-watt transmitter, and the most comprehensive collection of inventions by the iconic Powell Crosley Jr. Also on display is a huge antique radio exhibit and R.L. Drake's personal collection of most every Drake amateur rig ever made. This is a unique opportunity to see amateur radio in action and have a chance to get on the air from WC8 VOA. Admission is only $5 a person. The museum is located close to historic WLW-AM and tons of shopping and restaurants. Take a trip to the VOA Museum or visit us online at voamuseum.org.
Join the conversation. Call us on voice with Skype at Ham Talk Live or give us a call at 812-NET-HAM1. That's 812-638-4261. Now, here's more Ham Talk Live.
Everyone in the audience on Ham Talk Live today is going to get one of my favorite things. You get a 5-9. You get a 5-9. Everyone gets a 5-9.
Ham Talk Live's on the air every Thursday night at 9 p.m. Eastern Time, right here at hamtalklive.com. Be sure to check us out on Facebook, Twitter, and Instagram, and Over on Facebook a while ago, I posted some pictures from the National Voice of America Museum of Broadcasting, so check that out, and hopefully you can visit them at some point. I know we'll be talking more about that later, but they're usually open during Hamvention weekend, so if you go to Hamvention, maybe you can run down and visit the museum. Well, it's time for your calls now. If you have a question for Jerry from AMSAT, give us a call. The time is now. So let me give you that phone number again. It's 812-NET-HAM1, 812-638-4261, or you can Skype us. We're Ham Talk Live on Skype as well as on Twitter, and you can tweet your questions to us. And while we're waiting to see if we have some questions, Jerry, you kind of teased us here a little bit with the next project coming up, and that may have some attitude control to it. So tell us about the new project that you're going to be working on.
Very good. The Fox 1 being the first CubeSat AMSAT's built, we learned a tremendous amount from it. And the CubeSat form factor is the current way to go to space. So what we're looking at with the next project is called GOLF. And that's an acronym for Greater Orbit, Larger Footprint. And the greater orbit, in other words, the higher your orbit is, the larger a footprint, the more area of the Earth the spacecraft can see, and therefore you have a wider area that you can span with two stations talking to each other. So Golf is also, because we had Echo was AO51, and then Fox is the various Fox 1 CubeSats, 5 of them that we built, and so Golf is also the next letter, and phonetically Golf is the word. Golf T is going to be the first one. And what it is sort of a rapid deployment of this technology. We are going to put attitude, determination, and control, and we will have deployable solar panels. It's going to be a 3U CubeSat form factor, which is basically 12 inches tall, if you will, by 4 inches by 4 inches per side. It's like 3 1U CubeSats stacked up. This will give us an opportunity for more power, more room inside for batteries, and the ability to deploy the solar panels. The attitude, determination, and control allows us to point the satellite for either maximum power with the solar panels or to point antennas. And one of the things that we're moving toward is to use microwave bands for a couple of reasons. The VHF and UHF are extremely crowded right now. Microwave bands, of course, have megahertz, tens of megahertz available that give us the opportunity to, spread out, have a lot more signals, a lot more going on. And if you add a couple digital techniques with that, then you can get quite a bit of interesting stuff going on within the microwave bands. So we're going to be flying some prototypes or precursors of that as we work toward, or as we develop our 5 and dime concept. 5 and dime is the name we coined for the 5 gigahertz uplink and 10 gigahertz downlink, or C-band and X-band, that we'll be using. Those are bands that have a lot of bandwidth available, as I said, to amateur radio for satellites, and they give us, of course, with the smaller wavelengths, you don't need as big an antenna. You can use horns and patch antennas and such, and that's where the satellite pointing can come into play, to be able to get higher gain at higher altitudes. Which, of course, if you want to try to get gain with a 70 centimeter or 2 meter antenna, you're talking about a pretty large antenna. So we're pretty excited about that. That's going to give us the chance to be able to begin using these various things. And the golf program in itself is designed to be a stepping stone as we learn and develop these technologies to get to HEO, back to the highly elliptical orbit, which are the ones that would cover a hemisphere for about 12 hours a day, like AO40, AO13, and AO10 in the past. We have a program within AMSAT called ASCENT, which is an acronym for the Advanced Satellite Communications and Exploration of New Technology. It's a skunk works, essentially, with a bunch of engineers who I just let go off and do what they will, what they wish, and play around. And the idea is that they come up with some very cool ideas about that we can apply to future satellites, like the microwave, the digital, various attitude control and thrust. And so the Golf series gives us an opportunity to be able to take these things that they're developing. And as a matter of fact, some of the purposes of the Golf T mission were driven by what Ascent has created, and test them out in space in a lower Earth orbit, which is less expensive, so to speak, so that we can develop our confidence and the capability and the systems to be able to put something up into a higher orbit that will be reliable. As I said, we want it to stay up there as long as we can. So that's all coming together very well in this sense. We've got a lot of people coming up with great ideas. We look at the mission opportunities we have, the launch opportunities, and we put those together to come up with this opportunity. Golf T won't have any. Well, it will have one experiment on it from Vanderbilt University, a radiation experiment, which is similar to what was carried by Fox 1A, AO85, and Fox 1B, AO91. The Golf 1, which will be the first official series after we do the rapid deployment and development, will carry an experiment with a camera, so that'll be another interesting one. And the ability to point the satellite aids that quite a bit, because then we're not just seeing random views when the photo's taken, if you will, but we can actually look for particular areas pointing toward the Earth or toward the moon, what have you. It's going to be quite an advance. It's going to be very, very neat, and I think it will help us rapidly get back to the highly elliptical orbit. The higher you go, the more expensive it is. So one of the things that's an obstacle for getting to higher amateur radio satellite orbits is that it's become pretty pricey. To put our 1U Fox satellites up into low Earth orbit, which is around 500, 600 kilometers, it costs approximately $125,000. That's the manufacturer's suggested retail price, if you will, on a launch. But then if you triple that into a 3U, you're talking about $300,000. And as you go up with a 3U to a geo transfer orbit, or GTO, which is basically a highly elliptical at the equator, you're talking about $900,000 for a 3U satellite. So it costs a lot of money to get there, and especially when we do go for that launch, we want to make sure we have something that isn't going to be a $900 test, but we want to have some good solid practice and understanding behind it. So I expect that over the next 5 years we will have put up several Golf satellites that gives us an opportunity to develop these techniques and be looking for those launches that'll get us even higher.
Well, and some exciting stuff coming up. I look forward to hearing how that goes with the attitude control and everything. That's pretty cool. So let me give you that phone number again. It's 812-638-4261. It spells out 812-NET-HAM1. If you have a question for Jerry, or you can tweet us. Now's the time to do that. We have a few minutes remaining in the show, so if you have something that you want to ask, like Tom Crow here, N5TTI, he wants to know, were there any major adjustments made between Fox 1A and 1D? The reason he asks is because 1B seems to be much easier to work than 1A.
And that's right on. There weren't any design adjustments made per se. Fox 1A, the first one up, AO85, it is hard of hearing. In other words, it's not as sensitive as we had planned, nor as we would like to see. The Fox 1 series was designed to be able to be worked with a 5-watt handheld radio and a handheld antenna like an Arrow or an Elk antenna. And AO85 is on the edge of that. The problem is that in putting it together, when we had the flight model together, the antenna is soldered onto the solar panel. The antenna is a whip made of nitinol wire. So what turned out is that the solder basically cocooned around the antenna. And we, of course, didn't know that until it just came out of the solder like maybe 2 weeks or so before we were due to go to environmental testing and hand it over. So at that time, looking at what our options were with it, one thing you don't want to do is take a satellite apart, because then you have to retest everything that you've done up to that point. It was opted that and it had been tested before on Earth, that if we use this conductive epoxy to hold it on, that should satisfy the need of getting it on there quickly and the least intrusive way of doing it. So we did do that, and we also added some regular epoxy over that just for strength. It turns out that in doing that, some of the epoxy apparently overlapped some of the traces. It was just a little bit outside of where the solder would have gone on the circuit board traces, and it wound up detuning the antenna. And that was our determination once it got to orbit, that was the reason that Fox 1A is hard of hearing. So with the subsequent Fox satellites, especially since the solder didn't hold, we came up with a new technique for soldering the antennas. So that was the design change, if you want to call it that. And Fox 1B, C, D, and E will all have that new change. Fox 1B, or AO91, proved that the new technique works, and that the cause for AO85's hearing problems is the antenna. So we corrected that. Fox 1D seems to also demonstrate it's very sensitive, with the HT and a whip type of contact, and that's what happened there.
Okay, good answer there. And Tom, thanks for tweeting into us and asking that. And we've got a few other comments here. Robert, KE4AL, says, if you're stuck at work, nothing beats listening to Jerry. Great info and updates. And Jeff, WE4B, says, good show so far. So thank you, Jeff, and thank you, Robert, for listening. We appreciate that. And Robert Fitzpatrick, we'll see what we can do about the satellite cops. I don't know if we can get any of those launched or not, but Jerry, this is kind of a crazy thing, but I'm going to say it anyway, because sometimes I just say things that come to mind. One of the things that I've always joked about it, and I have a chemistry degree. I teach chemistry, so I'm always interested in the science experiments that go up, as well as the ham radio. And so one of the things that we always have joked about over the years was, wouldn't it be nice to do a radiation study at the Dayton Hamvention and just see how much radiation is being produced by all of those hams all in one place. So you were talking about the Gulf satellite and doing some radiation studies and being able to maneuver and point the cameras and point everything in the direction. So let me throw this out there for the team and say, can we do a study on the electromagnetic radiation coming out of Dayton in May?
That's an interesting thought there, that everybody does an RF exposure study, or at least considers it. I wonder if they take into account what happens when you get a whole bunch of hams together. Do you need a massive one? So the radiation that I referred to, of course, is of your high energy particles type of stuff, because in space, one of the things that we deal with is you've got these high energy particles either trapped in the Van Allen belts and the radiation belts around the Earth, or cosmic rays, or particles coming from the sun, and those are heck on electronics. Of course, you can buy radiation hardened components, but they're really expensive. I mean, a $1 or less typical commercial off the shelf chip could cost, like, for example, $400 for a radiation hardened version, and those are slightly made up numbers, so don't call me on that. But that's one of the things that we're working with is, in part of the design that we talked about at the beginning, is finding parts that can withstand the radiation. CMOS is something we generally tend to avoid because it can latch up. It's called a single event latch up. And what happens is a particle gets into the substrata there, and it essentially turns it on and leaves it stuck that way, creating a short, and you wind up with a high current flow. But the Vanderbilt University experiments that they're flying, they actually put commercial off-the-shelf parts such as memory on on a board, and they fly it up there, and they look at the amount of radiation exposure it's getting by loading a pattern into the memory, if you will, ones and zeros, and then watching it change over time as low energy protons hit it and flip the bits. And that helps everybody in looking at the opportunity for lowering cost by being able to characterize and select commercial off-the-shelf components that'll work. As far as RF radiation, electromagnetic, that we're used to dealing with as hams, the Fox 1 series gives us an opportunity to do some mapping of the Earth. I meant the Gulf. And by being able to point, we have considered that, looking at Earth in various wavelengths as we orbit and seeing just generally a signal level, as you pass over various countries or the oceans or what have you. Something like this was done with AO51, and they actually did some mapping like that to look at what goes on the frequencies that they had, which was 2 meters, 70 centimeters, and there was a receiver on 1.2 gigahertz, the L band. So that had been done before, and we're considering looking at the idea of continuing it, especially into the microwave. Is an interesting thought because that's where we're going to want to go. So you don't want to be picking up taxis on microwave with our future satellites or something, and which has happened. That 2 meter band gets to be used around the world a lot by non-hams.
Well, so maybe I wasn't too far off then.
You got it. Now focusing on Dayton,
yep,
I don't know if we got that resolution yet, but I'll tell you what, might be able to get a picture. How's that?
There we go. Now that would be a picture of Hamvention from outer space. There we go. Hey, we got a tweet in, but we are down to about a minute here, and before we sign off, sorry, I got to ignore the tweet there that came in. But if someone is interested in helping out in some way, whether it be building or donating to the cause at AMSAT, how do they do that?
Everybody's welcome. First of all, the way to do that is to go to the AMSAT website, www.amsat, that's Alpha Mike Sierra Alpha Tango, .org, and there is a link in the menu bar to how to help AMSAT. And volunteers are something that we need a lot of, because everything that's done here is done by people that are just doing this for fun, essentially. Engineering, we can always use volunteers because there's a lot of work to be done, and of course it cuts the risk of a mission by being able to have more than one volunteer working on something, because real life often interrupts what we do in our hobby, as you well know. If you can't volunteer time, then money, if you will, is there's more than engineering. Check the website. There's a lot of other things you can do to help, but also money is useful because that helps to pay for these launches. They're getting expensive, and the building the satellites. So anything you can do, if you can send in $5 a week instead of buying a fancy coffee, that makes a big difference. I mean, over a year, you've bought one of the systems on a Fox 1 satellite. So.
Okay, well, there you go. And amsat.org. And the tweet here is from Don, KB2YSI, and he says, give Jerry and all of HamSat a huge thank you for the most fun he's had in the last 15 years of ham radio. He started working the birds after Dayton last year and enjoys the challenges. So we're going to have to end it there, but Jerry, thank you so much for coming on, and we may be talking to you again soon.
Thank you again. Have a good night.
All right, that's a wrap for this week's Ham Talk Live. Thanks to Jerry and everybody for listening. Next week, Rob Sherwood, NC0B, is going to be with us. We're going to look at the ICOM 7610 numbers that he got a hold of. For a list of all of our upcoming guests, visit hamtalklive.com. For now, this is Neil Rapp, WB9VPG, saying 7375, and may the good DX be yours.